Our planet, Earth, a swirling blue and green oasis in the vastness of space. Today, it teems with life in countless forms, but it wasn't always this way. Imagine, if you will, a time before life. 4.5 billion years ago, our world was a fiery, hostile place, a swirling mass of molten rock and gas, constantly bombarded by asteroids and comets. Gradually, over millions of years, this young Earth began to cool. The molten rock solidified into a crust. Water vapor in the atmosphere condensed, forming vast oceans. This was the Hadean Eon, a time of immense heat and upheaval. It was in these primordial oceans, teeming with dissolved minerals and energized by volcanic activity, that the seeds of life would eventually be sown. The early Earth, though cooler than before, was still a volatile place. Volcanic eruptions were commonplace, spewing lava and gases into the atmosphere. The air was thick with carbon dioxide, methane and ammonia, gases that would be toxic to most life forms today. Yet within this seemingly inhospitable environment, the miracle of life was about to unfold. It's difficult to comprehend the sheer scale of time involved in these early stages of Earth's history. Imagine compressing the 4.5 billion years since the Earth's formation into a single day. On this scale, humans wouldn't appear until the last few seconds before midnight. The vast majority of Earth's history took place in a time before even the simplest organisms existed. The Archean Eon, beginning around 4 billion years ago, marked a turning point in Earth's history, the emergence of life. How exactly life arose from non-living matter remains one of science's greatest mysteries. But we know that within those early oceans, simple organic molecules began to assemble themselves into more complex structures. These were the precursors to life as we know it. These early life forms were incredibly basic, single-celled organisms known as prokaryotes. They thrived in the harsh conditions of the early Earth, obtaining energy from chemicals spewing from hydrothermal vents. Over millions of years, these early prokaryotes evolved and diversified, eventually giving rise to a new form of life, cyanobacteria. The arrival of cyanobacteria marked a pivotal moment in Earth's history. These tiny organisms possessed a remarkable ability, photosynthesis. They could harness energy from the sun to convert carbon dioxide and water into sugars, releasing oxygen as a byproduct. This process, which we take for granted today, had a profound impact on the planet. As cyanobacteria spread through the oceans, they released vast quantities of oxygen into the atmosphere. This led to what is known as the Great Oxidation Event, a dramatic shift in the composition of Earth's air. Oxygen, once scarce, began to accumulate. This paved the way for a new era of life, one dominated by organisms that could breathe oxygen. The Proterozoic Eon, spanning from 2.5 billion to 540 million years ago, witnessed another major leap forward, the emergence of eukaryotes. Unlike prokaryotes, eukaryotes have cells with a nucleus containing their genetic material. This innovation allowed for greater complexity and paved the way for the evolution of multicellular life. The Proterozoic was also a time of dramatic climate change. The Earth experienced several periods of extreme cold, known as snowball Earth events, where much of the planet was covered in ice. These harsh conditions likely spurred further evolutionary innovation as life adapted to survive in extreme environments. As the Proterozoic Eon drew to a close, life on Earth was poised for a dramatic transformation, the Cambrian explosion. This period, marking the beginning of the Phanerozoic Eon, saw an unprecedented burst of evolutionary diversification. Within a few tens of millions of years, most of the major animal groups we know today appeared in the fossil record. The Phanerozoic Eon, encompassing the last 540 million years, is divided into three eras: Paleozoic, Mesozoic, and Cenozoic. The Paleozoic era witnessed the rise of fish, insects, and amphibians as life ventured onto land. The Mesozoic era, often called the Age of Reptiles, saw the reign of dinosaurs, but also the emergence of mammals and birds. And finally, the Cenozoic era, which we live in today, is the Age of Mammals, a time of incredible diversification and adaptation following the extinction of the dinosaurs. Throughout Earth's history, there have been periods of great upheaval when life has been pushed to the brink. These mass extinction events, often caused by catastrophic events like asteroid impacts or volcanic eruptions, have reshaped the course of evolution. The most famous of these, the Chicxulub impact 66 million years ago, wiped out the dinosaurs and paved the way for the rise of mammals. Following each mass extinction, life has always found a way to recover, albeit in new and unexpected forms. The survivors of these events inherit a world transformed, with new opportunities for evolution and diversification. The rise of mammals following the extinction of the dinosaurs is a testament to life's resilience and adaptability. And then, relatively recently on the grand scale of geological time, came humans. Our species, Homo sapiens, emerged in Africa only around 300,000 years ago. Yet, in our relatively short time on this planet, we have had an outsized impact on the Earth and its ecosystems. The Anthropocene, a proposed new epoch in Earth's history, recognizes the profound influence of human activity on the planet's systems. From the first single-celled organisms to the incredible diversity of life we see today, Earth's story is one of constant change, adaptation, and resilience. Understanding our planet's past is crucial for navigating its future. As we grapple with the challenges of the Anthropocene, we must remember that we are part of a web of life billions of years in the making, and that our actions have consequences that will resonate for generations to come.